is how to download this IBM ILOG CPLEX Optimization Studio, and then how to install it. So let me give you a brief overview, or you can say brief introduction about the CPLEX. So basically, CPLEX is a commercial optimization solver. When we are talking about IBM ILOG CPLEX Optimization Studio, so in this particular studio, we have a programming language, which is a OPL programming language that is called as Optimization Programming Language. Whereas this studio has two commercial solvers. One is called as CPLEX solver, another is called as CP solver. CPLEX solver is actually used to solve linear and mixed integer linear programming and other such mathematical optimization problems. Whereas the CP solver is used to solve the constraint programming problem, which is a special kind of mathematical models, which do have some such constraints like OR type of constraints. So in this video series, our focus will be on how to use the CPLEX solver. So basically, CPLEX is the combination. This word is come from Plex is the simplex method, which is a very famous method to solve the linear programming problem from the Professor Danzig. And because this simplex method is written in C programming language, so that's where they have come up the name CPLEX. Because earlier it was the product of IBM, ILOG product. That's why they have ILOG. And a few years back, IBM bought from the ILOG, so that's where the entire name was IBM ILOG CPLEX Optimization Studio. So in order to download this IBM ILOG CPLEX Optimization Studio, you need to go to this link. So I will provide this link in the description of this video. So you should go to this link, and then what you need to do, so in order to download, either you can download the free edition or either you can download the free academic edition. So the difference in that, if you are going to use simple free edition, then you wouldn't be able to solve the practical size problem. They have some restrictions in this particular version. But the academic version is purely a professional CPLEX solver, so you can solve the practical size problem. So I would recommend try this version. But for this particular version, the academic version, you must have the email address from your institution. Okay, so the email that was provided by your university or your college. So that try that email address and register yourself first of all in the IBM. Okay, how you can register that is you should go to my IBM log and then register yourself. That is very easy because I have already registered myself and I log in with my email address from the academic. So once you log in this particular website, then you need to click over here, access free academic edition. So once you click over here, so it will take you another website which is look like this one. Okay, so once you come over here, there is a software link. So click software, and then they have multiple types of software, but we are going to download ILOG CPLEX Optimization Studio. So the latest version right now we have download version 12.10. So I will click over here, and then it will take you another website. That is this one. Okay, so what you need to do, so they have provided us the two methods, downloading method, either the direct one or either HTTP. Actually, I tried download direct, but I am facing some problem while using this option. I don't know what's the problem, but if it is working for you, you can use this option, but you should try this one because I use this one for downloading. I just downloaded this software, so you should click on this one. And then in order to download, we need to again click over HTTP. So once we click over here, then they are providing us the multiple options. We need to select whether you want to check the quick start guide with multiple language. I'm not interested in that, so I am interested in IBM iLog CPLEX Optimization Studio for Windows. So if you have other operating system like Linux, like Mac, Macintosh, so you can use that particular software. So I am clicking over here, then click agree, and then click over download. So once you click over the download, it will look like this form. So let me show you the. So it will look like this one. So in order to install this one, just double click over here, and it will start downloading, and the installation process is quite easy. So there is no complication for installing this software, because I have already installed it, so I am canceling it. But I don't think so there is any complication in the installation process, so that's why I am not showing you the entire process. It's very easy. So just canceling it, and once you install it, it will look like this way. So if I go to the start menu, you can click CPLEX Optimization Studio, and then CPLEX Studio IDE 12.10. So if I click over here, so it will look like IBM iLog CPLEX Optimization Studio version 12.10. So now it is starting, so I'm saying there's no need to ask me again and again the default option. So this is the outlook of this IBM iLog CPLEX Optimization Studio. So we are going to solve the simple linear programming problem using IBM iLog CPLEX Optimization Studio. So in order to do that, first we need to start the CPLEX Studio. So how you can do that, you should go to the start menu. After installing the CPLEX Optimization Studio, so go to the start menu. So you will find out CPLEX Optimization Studio 12.10 version. So right now I'm using it. So you will click on CPLEX Studio IDE 12.10. Okay. So once you click over here, so it will be look like this one. So this welcome to our CPLEX Studio will always shown once you start the first time. So in order to start, so we will click over here. So this is basically the CPLEX window is look like. So this CPLEX Outlook Windows has different functions, because right now we can see that window number 1, that is basically, so let me show you this one. Here in this video, we will write down the code of using the OPL programming language, that is called as optimization programming language. Then once we have written down the code, we will get the answers, and the answer will be shown over here. If you can see that this is problem, so we can get the answers over here. Okay, and whatever the project you will create, it will shown over here. So the project, or you can say you already have a project and you want to open it, it will, all the details will be shown over here. And the outlines are, that is basically just like the MATLAB, if you have used already. So you know that outlines means whatever the command we are writing down over here, it will shown over here. And the most important part is these windows. You can see that. So these windows are basically will be shown in order to get different kinds of, you can say, maybe there is some sort of errors while solving the problem, that would be under the problems. The answers you can see under the script, if especially we will discuss, there is a pre-processing, there is a post-processing, especially if you have written down the post-processing code, then you can see your results in script log. Otherwise, it will not shown over here if you haven't written the post script. But the solution you can get under this solution tab once you solve the problem. And then there would be a conflict and relaxation portions. that is, it might be possible that some variable or some constraints are conflicting with some other constraint that would be shown over here. And then the statistics section is also very important, because in this statistics section you will see the objective function answer as well as the you can see that the variables answer. Okay, this black graph over here, that is over time, that is in seconds, and y-axis, actually that would be the objective function answer. Especially this is very important when you are solving the mixed integer linear programming or a pure integer linear programming problem, because it will show you the breakdowns where at what particular time he got the feasible solution. So you can check that as the time is passing out, it is start branching it while solving the integer or mixed integer programming, and try to get the best feasible solution you can get that. Similarly, in a profile, it will show you the usage of the memory of your computer as well as the speed. Okay, so different kind of statistics you can see there. So in a starting perspective, so the important tabs for us are the statistics tab, where you can see the objective functions answer as well as the variable answer, as well as in a solution tab, you will see that. In script tab, you can also see the results, but only those results which you want to show after the post processing. So what is that? We will discuss that, as well as you can see the results over here in this particular window. So let me start a new OPL CPLEX project. So how you can do that? You will go to File, you will click on New, and then you will click on OPL project. Okay. So if I click over here, OPL project, so there is a new window came out, and they are asking us the project name. So let's say example 1. Okay, and then they are asking us the project location. So right now I'm doing that at the desktop just for the example. Okay, and then press OK. Okay, and then if you write down the description, so let's say I'm saying Go 1. Okay, now we can see that there is a create model, sorry, add a default run configuration, create model, create setting, create data. Because in OPL project, the first two things we must need it is, that is create model, because we are going to first of all creating the model to solve it, and in order to solve that model we need the run configuration. So right now we are going to do that and then finish it. So once we click over here, so now you can see that we have an example name, that is a project name, and the description is written after that. And then we have a run configuration, and then we have a model. So if we double click over here, that is basically the model fit. So they are giving us the welcome note. Now we can write down the code over here. So first of all, we can do the, as you know that in a programming language, comments are very important. So if you want to comment a line, a single line, then you can use double line. So this is my first program, the first OPL program. Okay, but if you want to comment the multiple line, then you should write down like over here, you should write down front slash static. Okay, this is my this is my first program. Okay, then static backslash. So this is how to you can how to comment the multiple lines. So this is how to comment the single. Okay, so now we are going to solve the first linear programming problem, which is very simple. That is this one. So we have objective function. We want to minimize it. Okay, and then we have only two decision variables with their coefficients 0.12 and 0.15, and we have three constraints, and then we have a non-negativity constraint. So in order to solve this problem, so what we need to do, we first need to define the decision variable. So in order to define the two decision variable that is of our problem, which is basically the keyword is dvar. Dvar is being defined variable. So we need to define the decision variable, and because we have two decision variables, we are right now defining dvar x. But before that, I have written down float plus. So there is a again keyword of writing down that what kind of this variable is, because this is right now we are solving the linear programming problem. So the float means the answer of this variable could be any fractional value, but due to this plus means the answer must be non-negative numbers. Okay, so the float plus x, that means this is a decision variable. What kind of decision variable? It can be any fractional value of this variable could be, but must be positive. Okay, so there should be no negative number of this variable can be in our answer. Okay, similarly, we have defined the second decision variable d bar y, and the next step is we need to define the expression. So what kind of expression we need to define? We need to define a objective function. So in order to define the objective function in using OPL language, that is optimization programming language, that is D express. D, that is define expression, EXPR. Then what kind of answer? Again, because we are solving the linear programming problem, so you can write down the fraction. Okay, so float. Okay, so because we want to minimize the cost, so I have written down a variable cost equal to the objective function, that is 0.112 0.12 multiplied by x plus 0.15 multiplied by y, and then semicolon. So this semicolon is indicating that the expression is completed. So remember that the semicolon is indicating the line of code is complete. Okay, so that must be over here again. So as I have already told you that the first two slashes is indicating the commit. So right now we are indicating that we are defining the objective function or the expression. Okay, the next thing is we need to write down the model with our constraints. So what we can do that, that is the model is we want to minimize this expression. So that's why I'm writing down minimize my cost, because the whole expression is stored in this particular variable. Then subject to, and now we have the set of constraints. Now you can see that OPL is a very friendly programming language in order to solve the mathematical optimization problem, because it is you write down the code exactly look like the mathematical model you have written on your notebook. Okay, so first, in order to write down the first constraint, that is basically this one. So how I am going to write down, that is 60 multiplied by x plus 60 multiplied by y is greater than or equal to 30, and then semicolon. Okay, so that means the constraint is finished. So I have written down at the upper side of this constraint is constraint 01 colon. So this is very good practice, because this is basically I am giving the name of this constraint. Okay, so this is very good practice, because the idea is we can use this name to display the shadow prices of the constraint, or you can say the dual prices, as well as the reduced cost, because with the help of this we will calculate these will use to solve the sensitivity analysis. Similarly, I have written down the second constraint and the third constraint, and block is finished. So that means we have defined the decision variable, we have defined the expression, we have defined the model. Now we need to solve it, but we need to do it. We will take this model and drag it to run configuration. If I drag over here, now you can see that we got the uh, got a new window, that is they are asking for us what we want to take the name. So right now I'm using the first, that is the configuration one, that is we have developed when we have defined the project. Okay, so you can also rename that one, that is using rename. So you can do that. That is basically the default one. Okay, so by the way, we have put over here, and now in order to solve the problem, what we will do, we will right click over here and then click that. Okay, so then press OK. So once we click over here, and the problem will be, and the CPLEX is start solving it, and now we are getting the answers. Okay, so where you can get the answer, that is under the problem, the solution with the objective function is point. So the minimum objective function is this one, the answer of the decision variables. So further, what we will get from the solution tab, we are getting, this is the entire thing they have written down. So different methods they have applied and whatever. The answer of x and the answer of y, that is the answer of the objective function. Similarly, if you go to the statistics tab, you are getting the objective function answer, how many constraints, how many variables are there, right? So these are the information we are getting. And if you come to the engine log, you will get the answer of the objective function. So I hope you clear how to solve the linear programming problem in OPL CPLEX Optimization Studio. So it's very easy. Okay. Now the next part is, let's do the sensitivity analysis. That is basically because we have solved the model. This is called as post-processing. After solving the model, we can do the post-processing. That is the part of one of them is the sensitivity analysis. Okay, so for post-processing, what we will need to do is, that is, we have written down, okay, we have in order to find out the sensitivity analysis, you can see the post processing, we will start a block called execute. Okay, then the block will start. I am writing down if, okay, then CPLEX right now, because we are using the CPLEX solver. So CPLEX, if I do that dot, so you will get a list of functions that you can use. Right now, what I am using, that is get CPLEX, okay, status. Okay, so because I have written down, that is, so get CPLEX status equal to 1. So this equal to 1 means once if this CPLEX is able to solve this problem, okay, then show me this. Otherwise, there is no need to write down the answer. Otherwise, they are saying else, write down, that is right line, error, solution is not found. Okay, so if you if CPLEX haven't reached the optimum solution, then provide us this particular line. Okay, so in order to perform the sensitivity analysis, what we need to do is, first we need to find out the reduced cost. That is basically with respect to the objective function, that is related to the decision variables that is involved in your objective function. So in order to find out the reduced cost, what we need to do is, I'm writing down right line ln reduced cost of x, comma, x again. So you can use x, that is the name of the decision variable, dot. Okay, so now you can see that. So either you want to find out the direction, the lower bound of this decision variable, the name. Okay, so I right now solution values, right now I am using reduced cost. So that is reduced cost. Similarly, I am finding the with respect to y is reduced cost. Similarly, the shadow prices are because linked with the constraints right hand side. Okay, so that's why giving the name of the constraint is very good option or a good practice. So that's why I'm writing constraint 1 dot dual, constraint 2 and constraint 3. Now again, if I drag to the run configuration of this model and then run again, press OK. Okay, so CPLEX is start solving it. Okay. So this is right now solving. Okay, now the solution is there. Again, we are getting the answer, but in a script tab now, we can see that the answer of the objective function, what is the reduced cost of the x variable, what is the reduced cost of y variable, and what are the shadow price against the first constraint, what is the shadow price against the second constraint, and what is the shadow price for the third constraint. Okay, so similarly in statistics, we are getting the answer. So in a script tab, once you have done some post processing, then you would able to see the reduced cost as well as the due prices. I hope you got the answer. So right now I'm not going to interpret what is reduced cost, what is shadow price. I think you already know that. If you don't know about that, you can watch my videos on linear programming using Excel. I have uploaded on my channel, as well as you can watch optimization linear programming problem using Python. Going to model a blending mix problem, and then we will solve that problem using OPL CPLEX Optimization Studio. So in our last video, we have discussed that there is a structure while we are modeling using OPL. Even you can say that whenever you are modeling the linear programming model using any particular mathematical optimization programming language, or even a computer programming language, while solving the optimization problem, you need to first of all specify the solver engine. So right now, what kind of solver engine we are using, that is a CPLEX, and what kind of programming language we are using, that is OPL, which is optimization programming language. Then we need to declare the data. Okay, so according to the relevant data of the problem, we need to define the decision variables. Then we need to declare the objective function and the constraint. So this is the structure of solving any optimization problem using any particular programming language. And then we also have discussed that in OPL Optimization Studio, we have two you can say solver engine. One is called as CPLEX and the other is called CP. CP stands for Constraint Programming Solver. So CPLEX is basically OPL using this solver by default. It's in a default setting. But if you want to use a CP optimizer, then you need to write down start of your program using CP. But if you still, although it is by default, you can still write down using CPLEX if you want to write down that I want to specify what kind of solver I am using. Otherwise, by default, it is using the CPLEX Optimization Studio. So the next thing is we need to define like what kind of data we can declare, what kind of variable we can declare in the OPL Studio. So basically there are 5 types of variable type we can declare, or 5 type of data type we can declare in OPL. But the thing is when you are using CPLEX solver, then there is a 3 types of variable type which we can declare. That is, one is the integer type. So we use to declare the integer type of data type or a variable using int. For real numbers representation, there is a float, and then for Boolean we can use the Boolean like the binary perspective. So interval and sequence they are using for the CP solvers, so we are not going to discuss this one. So we will focus on this one: integer, real, and Boolean. So in a last session we discussed the float perspective. But today we will discuss integer as well as float, because we are going to solve a linear programming problem. So some of the data would be the mix of integer and float, specifying the relevant data with respect to the problem. Okay, the next thing is while we are solving the mathematical optimization problem in the linear programming or the teacher programming problem, so there are different data structures are available in OPL, which is range, set, array, and tuple. So these data structures used to define different types of data storage, you can say. So right now in this video, we are going to discuss about two data structures. One is we are going to discuss set, another we are going to discuss array. So like how you can use set to define the data and how you can use array to define the data. So in OPL, there is a two-way to define the to define the data with respect to the set. Either you can use like what kind of set data values are, and then you can use the curly bracket around that type of you can say integer or the float. That is the curly bracket, which is indicating that this is a set type integer type structure. Or either you can use the name set of strings or set of integer or set of float, and then you can declare the set. So these are two way. Either you can use the curly brackets or either you can use the set of function. Okay, the second thing is if you want to use array, then you need to use this kind of brackets. Okay, so if array is normally using to define data as well as to declare the decision variables and to find out the decision variables. So in this particular video, we will going to use set as well as array. So the problem which we are going to discuss is that is basically the you can say the blending problem. Okay, that is this one, blending or the mixing problem. And the problem is that we have the 5 types of raw material. We have wedge 1, wedge 2, oil 1, oil 2, and oil 3. So these are the 5 raw materials. And the data is given that how much cost we are bearing against each raw material and what kind of hardness they are providing us, and how much for the production of the final product, what kind of price we are taking for selling it. Okay, so right now what we are doing that there is a 5 types of raw material, and using these 5 types of raw material we are producing a single product. Okay, so that means with respect to the 5 raw materials, we have the decision variable which is xj. That xj is representing the quantity of raw material we are using to produce a single product, and y is basically indicating the quantity of that final product. And this is the math model according to this problem. So I am not going to discuss how you build the model. You know that how to. I hope you know how to build this linear programming model. So now we are going to model it with respect to the OPL programming language. So this is the window which we discussed in the last video. So what each sub windows are representing. So in a previous video, we discussed that how we can define a new project like file, new, and OPL project. But in this particular video, I'm going to discuss how to import if we have already built a model. Like I have already built a model that now we are going to import it, like file import existing OPL projects, and I have placed it in my eDrive. This is the blending problem. Okay, then press OK and then finish. So this is the project which I have already defined. Then I'm going to click, that is dot mode means that is a model file. So if I double click over here, so this is my model. Okay, now I am going to describe this one by one. In our math model, so as we have discussed that we have the 5 types of raw material. So first thing, using the set, and we will use arrays as well. So using the set, we have declared the 5 types of raw material. So the raw materials are integer type, and this is a set. We gave the name raw material variable is equal to, so raw material is a set type of variable, is equal to 1, 2, 3, 4, 5. So 5 types of raw material. Similarly, we have 2 production lines, that is 1 and 2 production lines they have given us, right? So in order to produce these two things, so that is int set, that is production line 1 2. Okay, the next thing is they have given us the capacity of production line. Okay, so they have provided us that no more than this one. Okay, so these are the capacities that they have given us on two production lines. Okay, so that is veggie oil production line, non-veggie oil production line. So each have the capacity. So the next thing we have defined in a data set. Okay, so that would be int capacity of array type, that is a production line. One's capacity is 200, seconds capacity is 250. Similarly, we are indicating the per unit cost we are bearing against each raw material, that is this one. Okay, so we are again defining a data type integer type array, that unit per unit cost, that is this is the cost. So right now what we are doing, we are defining the model as well as we are declaring the data in a model file. We will discuss in the futures how you can define the data in a separate file. By the way, in this particular video, we are going to discuss like we are defining the data as well as model in a same file. So we define the you can say indices, that is raw material and product line. We have defined capacity as well as the raw material array. And the next we are going to discuss, that is a selling price. Okay, so this is the selling price, that is we are taking against the final product. And then we are indicating the float type of array, that is the raw material hardness, that is a 5 types of hardness against each raw material. And then they have given us the data against minimum finished product hardness and the maximum finished product hardness. So that this particular data is given over here, that is 3 and 6, that is required, the minimum hardness required in the final product and the maximum hardness required in the final product. Okay, so now what we have done, we have declared the indices, we have declared the data related to the product. So the first step now, in order to define the model, we need to define the decision variable. So we have two types of decision variable. One is with respect to the quantities of the raw material, and other is quantity of the finished product. So because we can define both in a continuous form, so d bar is a keyword to define, or you can say to declare the decision variable. Float plus, so we discussed this one in a previous video, that is, so because it's a linear programming, so that means the quantity could be the fractional value. So plus is indicating it must be the positive number. So you can also use plus over here. So but if you are not using plus, so that is also fine, but using plus is a good practice, because in plus sign, that is indicating that it must be the fulfill the non-negativity constraint. So we have declared the two types of variable like dvar, float plus raw material and raw material. And raw material are 5 types, that is over here we have declared it, that means we have declared the xj variable. Now we are going to declare the y variable, that is over here, that is a finished product quantity. Okay, the next step is we need to define the objective function. As we know that in order to define the objective function in OPL, we need to use the keyword dexpress, that is define expression. That is again linear programming problems. That's why we want that it could be possible. The answer should be in a fractional value. Profit must be equal to, so in a profit we are calculating the total profit, that is basically per unit cost, that is per unit cost is 150. So we define 150 in over here per unit cost multiplied by the finished product, that is y variable. Okay, minus, that is the cost we are bearing against the raw material. So that's why we are using the function called sum. Okay, so again this is a new thing. So the new function, this is basically in OPL is exactly like, that is basically in mathematics we are doing, that is I from 1 to And how many maximum raw material we have? 5, that is 5. So this sum is doing exactly the same thing which we do in this using this particular symbol. Okay, so sum I in raw material, unit cost I multiplied by raw material I. So per unit cost of raw material multiplied by the CN variable, that is raw material quantity of the raw material. So this is basically the raw material total cost. Okay, so if we do that, this selling price minus production cost, or you can say blending cost, so the answer would be is stored in a profit. And what kind of constraint we are doing? So in model, first of all, we need to define what you want in a profit. We want to maximize it subject to. So the first constraint is that is raw material 1 and raw material 2 that can be produced in a refinery constraint. So in a for refining with respect to the production capacity of that is the production line 1. Okay, so how we can define in a OPL, that is we will use for all J production line, and this sign is indicating that we are implementing the if condition within the for all. So in a model we can use this one, so you can use either this one, or either you can instead of using this one you can also write down over here if J is equal to 1. So it's up to you, whatever the condition type you want to use. So by the way, this particular column sign is indicating if J is equal to 1, okay, then this constraint should be used. So for all chain production line 1, when J is equal to 1, we are saying that sum I in raw material, again if I is less than or equal to 2. So that means only use raw material 1 and 2, because this is indicating raw material 1 and 2 is using to produce the final product that must be less than or equal to 200. So that's why we are saying sum I in raw material. If I is less than or equal to 2, then the condition is raw material I, which is x1 plus x2 must be less than or equal to capacity of J. And capacity of J means capacity of 1. Okay, so that is basically what that is 200. Similarly, for the second constraint, we are saying that x3 plus x4 is less than or equal to 250. So in order to do that, that is basically for the production line 2. So that's why we are writing down for all J in production line if J is equal to 2. So again, as I told you in the previous video, this is what we are doing. We are writing down the name of that constraint, and it's a very good practice because we will use this in order to find out to perform the sensitivity analysis. So we have written down the name of the constraint, colon sign, and again the sum I in raw material where I must be greater than 2. So for 3, 4, 5. Okay. So if I is greater than 2, then apply this constraint. So that means this would be equal to x3 plus, so this entire thing would be x3 plus x4 plus x5 must be less than or equal to capacity J, where J is equal to 2, that means this must be less than or equal to 250. So I hope you understand the first two constraints. Now we are going to write down the third constraint, that is this one, which is final product hardness limitation. Okay, so that is basically we are going to hardness constraint 1, sum I in raw material, that is sum of, that is raw material hardness I. So hardness, that is raw material hardness of I, multiply by raw material quantity, that is CN variable. Okay, this is raw material quantity minus minimum finished product hardness, which was a 3 multiplied by the final product, that is this one. So this must be greater than or equal to 0. Similarly, we are writing down the second constraint, that is hardness of 2. And similarly, we are writing down the third constraint, that is with respect to the weight equality. Okay, that was this one. Okay, so what this constraint, let me explain this one. So that is weight equality, because we are need to sum all these raw materials. So we are writing down sum I in raw material I minus finished product must be equal to 0. So this is the model we have written down. Okay, so now we can solve the problem, but let me explain how we can perform the sensitivity analysis. So over here, we can solve the problem. We can get the answer of x1, x2, x3, x4, x5 as well as y. But now let me perform the post-processing analysis, mean the sensitivity analysis. So in order to do that, we need to define the execute block after the model. Again, I'm writing down the condition if CPLEX dot get CPLEX status. So you can do that, right? As if CPLEX, you will write down the dot, you will get a list of functions available. So right now we are saying that I want to check the CPLEX status, mean the solution status. So if it is equal to 1, that means if CPLEX is able to get the solution, then do this thing. So here what we are doing, we are using basically the JavaScript. So in a pre-processing as well as in a post-processing of OPL language, we are basically using the JavaScript programming language. So if over here, we cannot use for all, we need to use for, we need to define a variable like for I, okay, in raw material, okay. So that raw material is a global. So which is, that is this one, okay. So for all war in raw material, I want to find out the reduced cost, okay, for every decision variable. So right line, so it will write on this line, I means 1, 2, 3, 4, 5 for every value with respect to the loop, raw material quantity dot reduced cost. So it will provide us the reduced cost against x1, x2, x3, x4 as well as x5. And this line of code will provide us against the y variable, which is the finished good quantities reduced cost. Okay, so in order to find out the shadow prices, which is also called as the dual prices, so for the first constraint with respect to the capacity constraint, we need to define for var j in the production line. If j is equal to 1, then that is a capacity constraint 1. Okay, so j is dot dual, that would be provide the shadow price against the first constraint and of the capacity constraint. Then similarly we will do the if j is equal to 2, then provide the shadow price for the second capacity constraint. Similarly we are computing the shadow price for, you can say, the hardness constraint. Again, this is here, I am also finding the slackness in this particular constraint as well. So dot slack will give us the slack value, mean the unused resources, whereas dot dual will provide us a shadow price. Okay, if these conditions are false, means if CPLEX is unable to get the optimum solution, then provide us a line of code that is error solution on. I hope you have got the idea how to write down the code. So let's run this. So in order to run this, solve this problem or run this code, what we need to do, we will drag this model and into the configuration, and then we will right click over here and run this. So once we run this, so we will get the answer. So the total profit would be equal to this one, and the answer of the decision variables are over here. Okay. Similarly, we can get this answer in a solution tab. So what's the answer of the objective function? Y variable. What's the answer of x1, x2, x3, x4? So that means how much raw material one we are used, 2, 3, 4, 5. And what's the quantity of the finished product, and what's the answer of the objective function. Similarly, you can get the objective function answer in an engine log, that is this one. Okay, as well as in a statistics tab, you will get the answer of the objective function. And further, they are also providing us the information regarding the number of constraints, number of decision variables, right? As well as how many iterations the CPLEX has performed in order to get the answer. Okay. Further, in a script doc, they are providing us the optimum answer of the objective function as well as the reduced cost against each decision variable. Okay, then shadow prices against each constraint, right? As well as we have also find the slack of this particular constraint and slack of this particular constraint, so you know how to solve. I hope you got the idea. Thank you so much. See you in the next video.